Welcome back to the session 3 of real numbers. In the second session, we have seen how to find the prime factors of the numbers. That is question number 1 using fundamental theorem of arithmetic. Now in today's session, we are going to see question number 2 of exercise 1.2, in which he is asking find LCM and HCF of the following pair of integers and verify that LCM into HCF is equal to product of the two numbers. Okay, so we are going to see this relation between LCM and HCF, and we are also going to recall how to find LCM and HCF, which you already learned in previous classes. So HCF and LCM you are learning from 6th class. Okay, again you have got the same concept here with few application questions. So let's begin with it. The question number 2, you can see here I have taken the question number 2. We'll find the LCM and HCF by prime factorization. Okay, first I'll find prime factors of 26 and prime factors of 91. Okay, like we have done for first question. So 2 13 times is 26 and 13 1 times. So the prime factors of 26 are 2 into 13. For 91 I can divide it with 7 13 times, then 13 1 times. So prime factors of 91 are 7 and 13. Okay, so what you used to do for finding HCF, you used to take common factors from both the numbers. So the common in both the numbers, the common factor is 13. So HCF of these two numbers is 13. That means both 26 and 91 can be divided by 13. Okay, they can be divided by 13. 13 2 times and 13 7 times is 91. Okay, now we found the HCF. Let's find LCM of 26 and 91 by division method, then we will verify. Okay, now finding the LCM, you have done this method in your previous classes, so we are finding by the same method. This is called division method of finding LCM. Okay, there are two methods of finding LCM and HCF. One is prime factorization method. Okay, prime factorization method. Another is division method. So we are using division method here because method is not mentioned. So finding the LCM, 2 13 times, then 2 won't divide 91, then 7 13 as it is, then 7 13 times, then 13 ones are 13, 13 ones are is 13. Then we'll multiply all this. Hope you remember this. We'll get the LCM. 2 into 13 into 7 is 182. Now there is a relation between LCM, HCF and the numbers. What is that relation? That is HCF into LCM is equals to product of two numbers. What are the two numbers here? The two numbers are 26 and 91. Okay, so when you multiply those two numbers and you multiply HCF and LCM, you get equal answer. Okay, so let's see how we get that. We need to verify it. So let's multiply HCF and LCM. Our HCF was 13 and LCM is how much? 182. So we'll multiply both LCM and HCF. We get 2366. Then multiplying the numbers. What are the numbers we found LCM and HCF for? Those are 26 and 91. So 26 into 91 will also give you 2366. So both are equal. That is HCF into LCM is equal to product of two numbers. Okay, sometimes we write this product of two numbers as A into B also. Okay, we can write this product of two numbers as A into B also, where A will be one number, B will be the another one. Okay, so as the LCM and as this is equal LHS and RHS, so we can say that it is verified. Okay, so this happens for every number you take. Okay, this happens for every number. This relation is true for every number. Next, 510 and 92. So here also we found the prime factors of 510. Okay, next 92 also. Then we'll write both the prime factors in this way. Then what is common in both? 2 is common in both. There is no other number common, okay, in both. So HCF is 2. Then finding the LCM, we get the LCM as 23,460. After finding the LCM, we get the answer is 23,460. So we got LCM and HCF. Then again we can verify it by using the same relationship. HCF into LCM I'll take as LHS, and product of numbers is RHS. So when you multiply LCM and HCF, you are getting 46,920. And here product of two numbers, what were our numbers? Those numbers, the question itself, 510 and 92. These two numbers, 510 and 92, when you multiply, you'll get 46,920. It's quite amazing, isn't it? So LHS is equal to RHS, hence this is also verified. So this is the way we have to proceed with and verify the relation between HCF, LCM and the other two numbers. Next, even third bit I have done here and verified. You can check, we are getting the same answer. Okay, so we have learned one method of finding LCM and HCF. In the next session we'll see how to find LCM and HCF by prime factorization method. Okay, here method was not mentioned, you can follow any method, but here it's mentioned specifically by prime factorization method. So we'll see how to do that by prime factorization method. Thank you.